Welcome back. So today we are going to be talking about how to graph conics that are not in standard form originally. All right, so you can kind of follow along with me on this. It is very likely that this is going to be broken up into a couple of different parts because there are two main situations that we need to cover. Okay, so the first situation is what happens if instead of being given the equation just straight up, here's the equation, you're given some information or characteristics, and then you have to either figure out the equation or graph the function from there. So how can we do this? And then the second situation is, what if you're given the equation in what they call general form? So that's when it's just like a list of terms. And so you're going to have to do some algebra to get it into standard form, a little bit of converting. And you might be wondering, what is this algebra that my teachers are talking about, that Mrs. Fry is asking about? Well, that mystery will be unveiled very, very shortly. So we're going to do situation one first and then probably spend a lot more time on that second scenario. So with that, here's situation one. So the first thing that you want to kind of recognize is that you're going to make an equation that's in standard form based on that information. And we have a lot of different, equations based on our different functions that we can use. For example, if we're dealing with a parabola, remember one version we have is x minus h squared equals 4p times y minus k. Or we could have y minus k squared equals 4p times x minus h. If we were talking about a circle, remember we have x minus h squared plus y minus k squared equals r squared. And then there's still even more when we talk about an ellipse and a hyperbola. So sorry about that. Okay, so I also want to point out that every different conic, whether it's a parabola, a circle, an ellipse, a hyperbola, they all have different features. So even if we didn't straight up tell you, hey, this is an equation for such and such, you could probably figure it out just based on the types of things that we gave you in the problem. So, for example, the first question says, given a focus at 9, 4 and a directrix of y equals 2, write the equation of the parabola. We didn't need to tell you this for you to know you were going to be graphing or writing an equation of a parabola, because parabolas are the only thing that have a directrix. Okay, big recommendation. That's why I'm writing the word recommendation in big font. All right, strong recommendation in this first situation, draw or sketch the info, okay? Drawing that information out is really going to help you narrow down quite a bit of information, quite a bit of things. Okay, so in number 1, I've got a focus at 9, 4, so it'd be like 9, 4, so maybe somewhere here. And then I've got a directrix at y equals 2. So 2. You know what? Just to make this a little bit easier for you guys to see, I'm going to do this. So this is 9 and this is 4. And then I've got a directrix at y equals 2. All right. So it says here that I'm supposed to write an equation for a parabola. Well, the first thing you know is that the vertex is somewhere in between, and it has to be equidistant, okay? So if we're going from 2 to 4 to make it equidistant, that distance has to be 1 in either direction. So that means the vertex must be smack dab in the middle at 9, 3. And then because of that, we also know the direction our parabola has to open. It has to open up. Because if it opened down, it would run into the directrix, which it can't. And in fact, the parabola can't intercept the directrix, so it has to point up no matter what. Okay, so with all that information, I know an upward-facing parabola. Open, up. I know an upward-facing parabola has to be x squared, so that's going to be x minus 9 squared, equals, and then that distance, like this distance right here, has to be p. So that means it's going to be times 4, just 4, because 4 times 1 is 4, times y minus 4. And then I'm sorry, not y minus 4, y minus 3 from our vertex. And you don't need to distribute the 4. You should just leave it just like that. So that's your answer. All right, second scenario, we've got a vertex at 6. So 6, -5. So that's our vertex. And then we have our second point at 8, -7. All right, 8, -7. Now this is just a random point, okay? Not a point, like not any particular point, just kind of another point on the parabola. So at this point, it's a little hard to tell what direction the parabola opens because it could open this way, could open that way, and it's like, which way is it? So remember to use every piece of information that's given to you in the problem. So as you can see, it says there's a horizontal axis of symmetry. So that means the parabola must be symmetric this way. So a parabola is opening sideways, okay? So that's a y² parabola. So if I go to write my equation, I'm going to have y minus, well, -5, so y plus 5 squared equals 4p times x minus 6. So at this point, we're like 2/3 of the way there. But we don't know the p value, and we aren't going to be able to figure it out just by like using this space because that point isn't on the focal chord. So that point can be used in another way. That point is an x and a y, so I can use it here and here to solve for 4p. So that means I'd have 8, oh wait, sorry, -7 plus 5 squared equals 4p times 8 minus 6. Okay, so that's -2 squared equals 4p times 2. Now, this might seem weird to you, but I want to know what 4p is, so I'm just going to divide both sides by 2. I'm going to leave the 4p alone because that's what I want. And the -2 squared, that's 4, so divide that by 2 is just 2, so 2 equals p. So then my equation turns out to be 8 times x minus 6 on that right-hand side. All right, so that's how you deal with a parabola if you're given some information. Now, the circle, I'm going to let you guys try these two on your own, okay? So, because I think you can figure them out, okay? So take a moment, pause the video, and then after you've tried them, unpause, and we'll see how you did. All right, welcome back. So we've got a circle that we're trying to write an equation for. So that's x minus h squared plus y minus k squared equals r squared. So we're looking at x minus 1 plus y plus 5 squared equals, and then we were told the circumference is 12 pi. So the circumference is 2 pi r. So if I set 12 pi equal to 2 pi r, it would appear that r equals 6, which would make my r squared value 36. Ta-da! Okay, now I'm going to draw a little picture for us over here. And it looks like we've got a center at 6, -3. So we know we've got x minus 6, that quantity squared, plus y plus 3 squared equals, the question is, how do we find the distance between that point and this other point? Now, I recognize that there is no way I drew those in the right orientation, guys. That's really not what this is about. That's about me just showing you the fact that if you know the center and you know a point on the circle, the distance we're going to be finding is going to be the radius. So whenever we get our answer, we're going to have to square that number in order to put it right here, okay? So the way we're going to figure out what that number actually is we're going to use the distance formula. So we're going to take the square root of 6 plus 2, because it's minus a negative, and then we're going to add -3 minus 4 squared. And yes, you should be able to do this without a calculator. Come on, you got this. 64 and 49. Looks like the square root of 113. So then the number that I'm going to put right here is 113, because remember, this is r, but I want r squared in the actual formula, okay? All right, so moving on to number 5. Now we are being asked to do something with an ellipse. And once again, I'm going to say, draw this out. Okay, so it says our center is at 2, -1. It then says the vertex is at 2 and 0.5. Okay, now once you know a vertex, the vertex is always on the major axis. So that means that this length is A. Okay, so A equals 1.5. Or better yet, let's write that as a fraction, 3/2. It then says the minor axis is a length of 2. Remember, the minor axis is equal to 2b. So that means that 1 is equal to b. I should keep that lowercase just so we don't get confused. So that means I've got a point here and here in either direction. It also means that I have another point 1.5 units below. So I've got this itty bitty little ellipse. How cute is that? Right? Just this tiny little guy. Okay, so from there, we've got enough information to write our equation. So remember, our equation is like sum. So it's x minus 2 squared over something plus y plus 1 in this case squared over something equals 1. It's always an x squared, a y squared, quantities, and then equal to 1. And then we're going to put, under the denominator, we are going to put 1, which you could leave, like you could put nothing there, you know, and just not even write it as a fraction because you're just dividing by 1. That's because, oh wait, I'm so sorry, guys. Flipped that around for you. The 1 should be under the x because we went 1 unit left or right of the center. And then underneath the y plus 1 squared, we should have 9/4. Because remember, this is b squared, and this value underneath the y plus 1 is a squared. All right, so next one. By the way, feel free to pause me and try this problem if you want to before I go through the explanation. Big hint, obviously, just draw the whole thing out before you try to figure anything else out. All right, whether or not you've unpaused, I'm going to start graphing. So I've got 0, 0, and I've got 4, 0 as my foci, okay? The foci, the point in between them has to be the center. So the center for this particular ellipse, right, because that's what it says we're going to graph, is 2, 0, okay? And then this distance between the center and the foci has to be c. So c equals 2. Major axis, similar to the minor axis, this is 2a. So 2a must equal 6, so 3 equals a. So that means I've got vertices to the left and to the right of the foci. Just an FYI, the foci are always on the major axis. So if you're wondering how I knew to go left and right from the center, 3 units, it's because the foci were left and right of the center. Okay, so before I can finish graphing this, I need to figure out the b value. So remember, c squared is equal to a squared minus b squared. This is for an ellipse, okay? It's the opposite. It's positive if it's a hyperbola. So this means that 4 must equal 9 minus b squared. So then b squared has to be 5. So that's about, square root of 5 is about 2-ish, right? A little more than 2. A little more than 2. So then our ellipse is going to look something like this. All right. And then our equation would be x minus 2 squared over, what is that, 9? And then y squared, you don't necessarily need the parentheses, over 5 equals 1. All right. Last situation, last situation in problem in situation 1. Find the standard form equation of a hyperbola given the following. All right, so I'm going to do my usual. I'm going to graph all this stuff. Okay, so 0, 0, 8, 0, those are my foci. 3, 0, 5, 0. Those are my vertices. All right, all the important stuff has been on the x-axis, so it looks like we're going to get a point in the middle at 4, 0. Okay, so that's our center, is 4, 0. And then if you'll notice, the distance between the center and the vertices is 1. So that means A, not that it really matters, but I'll call it A. A equals 1. This distance, I'm sorry, the distance from the center to the foci is 4. So that makes C equal to 4. So in this situation, C squared, this being in the situation of the hyperbola, C squared equals A squared plus B squared. So 16 is going to be equal to 1 plus B squared. So that means 15 equals B squared. So B is about square root of 15. So a little bit less than 4. So 1, 2, 3, a little less than 4. A little less than 4. Okay, so there's this box going on right here. Okay, and now I'm doing this because we need to talk about what type of equation we're going to write. Remember, these asymptotes cut right through the corners, these corners of your box, okay? Which way does this open? Because that's going to help me determine how I write my equation. Well, given the fact that the foci are here, they're on the left, the right and the left, this has to open, this hyperbola has to open towards those foci. All right, and we're going to cut right through the box. So if it's a left-right opening parabola, that means hyperbola, that means we're going to start with x first. So it's going to be x minus 4 squared minus y squared equals 1. And then the distance left and right from the center was 1, so 1 squared goes underneath, and then the distance up and down was the square root of 15, so 15 goes under the y squared. Ta-da!